You can never solve a problem on the level on which it was created. That's a quote by Albert Einstein. And yeah, you'll find the significance as I go forward through it. I'm Geshan, and today I'm going to talk about you build it. Google runs it serverlessly in containers. Let's get started. As I said, I am Geshan, a senior software engineer at Simply Wall Street. I am a GD for Google Cloud Platform since 2019. Till now, of course. I am one of the GDG Cloud Sydney organizers. I've been using Docker since 2014, probably as soon as it was released. And I have dabbled with Kubernetes, since the time of its release around 2015. Just some context. As I said already, I work for Simply Wall Street. We help individual investors make long-term investment decisions. And as I said, we are hiring a senior full stack backend engineer. If anyone wants to apply, come in and ping me. I am originally from Kathmandu, Nepal, the only country that has a non-rectangular flag and is pumping probably around $4 billion to the Australian economy with all the students flowing in. I don't know what the visa changes are going to do to the economy, but yes, till 2023, a lot of Nepalese would have come into Nepal. Just a show of hands if you identify yourself as a Nepali. Thanks, nice. So let's get into the agenda. If you want to have a look at the slides, you can scan that QR code while I quickly go through the agenda. We'll start with Google's infrastructure and how it's built to handle billions of users. Then we'll go a bit into containers, Docker, and why use it. Then move on to serverless and the reasons to use it. Then get into containers without the de facto Kubernetes orchestrator and some serverless. Then the Google's container runner service that's going to come up. Similarly, we'll have a demo and then a conclusion at the end. I know it's a pretty hard act to follow after Dee. He is amazing at storytelling, but I'll try my best. So probably most of you know Google has many services, and at least 7 of them, I'm not counting Chrome and Android there, have more than 1 billion users. By that, they have servers that are actually serving more than 1 billion users on Earth. And probably this data is from 2022, if I'm not wrong. So maybe it has even increased now, where half the world basically uses Google search, or maybe more than half now. The thing that I'm trying to point out is Google builds their infrastructure for scale, planet scale, a lot of users. They do also get a bad rep for killing products. I think they recently killed something that had 500 million users just a couple of weeks back. But anyhow, as long as there are 1 billion users, I don't suppose they would kill it. That's my philosophy. The thing is that everything at Google runs in containers. They were basically the people who were using and utilizing containers before they became more democratized, let's say, right? So it helped Google's development teams to move fast, deploy software efficiently, and operate at unprecedented scale, of course, at billions of users, right? So containers actually helped Google reach that scale and operate at it probably a bit easily. Google internally uses a container orchestration system called Borg, which you could tell as the predecessor of Kubernetes. Kubernetes is more like a modified open source version of Borg. What actually runs inside Google is still Borg. And yeah, I think towards 2017, 18, Kubernetes won the container orchestrator war against contenders like Docker Swarm and others that were there. And basically, by now, it would not be a false claim that Kubernetes is the de facto container orchestrator. Again, with all of this, we're talking about containers. So what are containers? As per Docker, is a standard unit of software that packages of code and all its dependencies so that you could run your application quickly and reliably, regardless of the environment, right? So some of the things that are important here is the standard unit packages everything and all of its dependencies. Basically, you're shipping the whole stack, the OS, the runtime, your code, any other dependent code, every time you deploy. For example, if you use something like Capistrano, you would only change your code and the dependent code, not the other parts of the stack. Whereas with containers, every deployment you make, you ship the whole thing. So as I said, you ship the whole stack and all its dependencies, which makes it a lot more predictable and reliable. Basically, if it runs on your machine, or if it runs on your container on your machine, it could run equally well on staging because you're shipping containers and not just the code. It is easier to scale compared to a virtual machine, and it has much better resource usage. By that, I mean on your local machine or even on this Mac, if I run hundreds of containers, it should hold up. It will work pretty easily. But if I happen to run, I don't know, just 10 or 12 VMs, it will blow up. It will surely blow up. So that's like a much better use of the resources that you have. With containers, you essentially become cloud agnostic. By that, I mean, as long as your containers run on some flavor of Kubernetes, and virtually, if you could move your data in any of the clouds, you basically can go jump from one cloud to the other. Some companies have done it. One of my previous employers has actually done it. They moved from AWS to Google Cloud. And I guess it was possible only because we were all of the apps were running in Docker and containers. From a developer's point of view, it's also very good because you could potentially be productive on day one. By that, I mean someone could come in, clone the repository, run to Docker Compose up commands, get a coffee, take a break, and hopefully their whole stack is running. Compared to that, for example, if I remember 2013, when I had to start at a company, 1213, I had to know the exact version of PHP, the exact version of Solar and everything. And I had to get all of them properly configured on my machine. And that easily took a couple of days. So compared to that, you have all of them declared in files, basically Docker Compose files. You go in, you type Docker Compose up, you wait for it to download what it needs to, and it's there. You saved at least a day. So this is how Docker turns an image into a container. So an image is basically a static artifact, and once it starts running, then it's called a container. You basically define a file, which is called a Docker file, that you could start from Node or I don't know, Java or anything that you would use. You have your steps defined into it. You use Docker or any other builder to build it into an image. A Docker image or a container image or even an OCI compliant image at that point is pushed to a container registry, right? And then wherever it needs to run, it is being pulled and then it is executed or ran. For example, it could run on maybe some people's favorite here, de facto Kubernetes, or you could potentially run in something else that is a container as a service. And that's where we'd go into slowly. So as I said, a container could be run serverlessly, right? So what does serverless mean in this context? As for IBM, it's a computing paradigm that enables developers to build and run application code without provisioning or managing servers or backend infrastructure. So basically, there's nothing to manage. You throw your code over the wall and magically it runs. That's serverless. The important point IBM makes there in that particular definition or that particular post is with serverless, developers never pay for idle capacity. You use it and you only pay for the time you use it. There are other factors of serverless as well, but I just remember these two. These two are the important ones, that you don't manage anything and you pay only for the time that you use. But if you look at it, there are still servers. It's not that there are no servers. The word serverless is, how would I put it, a bit deceptive. But anyhow, the good thing is there are servers, but you are not the one who's managing them. Someone else is managing it. It's just offloading it to someone else, which happens to be generally one of the three big cloud providers here, right? And some of the reasons to use serverless, as I said, there might be servers, but you don't care about it. Abstract it away. You don't need to manage any servers. The cost is precisely as per your use, and it's very highly scalable. That's basically what serverless is about, that it's scalable and it's highly available because it can scale pretty rapidly. If we talk about function as a service, yeah, you could go from hundreds, thousands of requests pretty easily, right? The other good thing is if your app doesn't get any traffic for a week, you pay nothing. That was one of the pillars, right? That says serverless. If you don't get traffic, you don't pay anything. And then the deployments are faster. And the good thing is you can go to the market much faster because now you're thinking about your code, your infrastructure, not your infrastructure, your code and your features. And you're just uploading the infrastructure part to the people who do it, not the best, but pretty well, which are the big three cloud providers. If you want to learn more about serverless and the good things that it has to give, you could check that URL. If you had scanned the QR for the slides, you could go there. But then again, we talked about containers and serverless. Now let's change gears on how to run containers. Like basically, you could take those actual physical containers as your application containers and this big ship as Kubernetes, right? But my general opinion is to run containers, you don't necessarily need to learn Kubernetes. Why? Because Kubernetes is complicated. It's goddamn complicated. A way just to understand deployment, you'll need to think of this. Like a deployment gives it to replica set, a replica set gives it to pods, and then there are X number of containers inside the pod. Yeah? Just the simple deployment is complicated. You peel more layers, and then you find out that you don't know where your application is. There are load balances, there is ingress, there is kube proxy, there is kubectl, there is this, there is that. There are like 20 different things. There are 20 different things, and then somewhere there, you might just find your application. Okay, you anyhow hopefully learn most of these things, but then you face this big iceberg of Kubernetes, which surely says that it is not easy to learn Kubernetes. But again, you want to run your containers, right? That's the goal, because as we just found out, there are many advantages of running containers. But I have a different opinion that should you run it in Kubernetes. So you can go to cloud and run Kubernetes and run containers without Kubernetes. Stated, proven, Kubernetes is complicated. The thing that you need to do is focus on your application code and business logic. Containerize your app, yes. Then run it without Kubernetes. If you need to actually go in and run into Kubernetes, you could do it, because at the end, Kubernetes runs containers. It just orchestrates containers. So if you need that power and need that flexibility, maybe you could go into it. But if you don't need it, you can start with something else. That's where it comes, that you build it and someone else is going to run it. Someone else is going to operate it. Someone else is going to scale it for you. Now, with all of this, I would ask myself, does that magic potion exist? Let's see if it does. Coming back to the title of the talk, Google runs it in containers serverlessly. Imagine having Google or Google SREs manage all of your scaling of all of your apps. It would be nice. The only thing that you need to do is specify resources, CPU, memory per instance, and the minimum and the maximum number of pods or containers or whatever you want to call them for that service. That's your job. That's it. Everything else is Google's responsibility after that point. Google will look at the traffic and then automatically scale your service every X seconds, depending on the CPU and other resources. To be honest, it's like having a separate Kubernetes cluster for each of your deployment. They don't overlap, no noisy neighbor problem, none of that. You basically outsource all of these complications to the people who actually build Kubernetes, Google. And yes, that kind of a service exists. And that magic potion is called Google Cloud Run. Google Cloud Run is a managed compute platform that automatically scales your stateless containers, abstracts away all infrastructure management so that you can focus on what matters the most: building great products, your code, your feature, your service. There are multiple advantages of Google Cloud Run. The first one, of course, being you don't need to learn a new language or a framework, a new paradigm. For instance, if you do function as a service, one request, one function, you'll need to really think of statelessness and everything. Function as a service, let's say you want to run, I don't know, Rust, and they don't support it. You can't do it. With Cloud Run, as long as it can be containerized, it can be run on Google Cloud Run. Serverless and fully managed. You don't need to think of servers or anything else. As I said, specify 4 things: memory, CPU, minimum instances, maximum instances. Done. Google will scale it up for you every 5 seconds, looking at the resources. If there are no requests coming in, you pay nothing, because it will be scaled down to 0. If your minimum instance is 0, that is. You also get like HTTP URLs, HTTPS URLs, and custom domain support out of the box. You don't need to pay anything else. You could just get a domain and point it to Google Cloud Run, start using it. Some more advantages: you could potentially manage traffic percentage and concurrency per instance. For example, if you want to do it with Kubernetes, I don't suppose it's easy. You could ask someone like Dee or Adish, they might know better, but unless you have a service mesh and something like Istio, I think it would be a headache to do it, right? Well, with Cloud Run, like it's just there, it's just in the UI. You just configure it, set the percentages, hit 3 buttons, done. You could even have URLs for each revision. You can just tag it, and then it gives you another URL. I'll probably try to show it in the demo if I get time. With the new features of Cloud Run, you can have things like Cloud Run jobs, which is basically a cron job on Kubernetes, and or if you know cron jobs that run until execution. That doesn't only support HTTP traffic, so it could run for hours, as far as I remember. And then there are other integrations for things like cloud storage, Cloud SQL. You can even have sidecar containers in Cloud Run now. The usual things like health checks, and then only after the pod is healthy or the container is healthy, then it gets requests. So you could do all of that. With cloud storage bucket as a volume, you could potentially host a static website on Cloud Run. You change the files on the bucket, and then it would reflect on the service. So you can do all of that now. Serverless till now, you could go unserverless with just one configuration. Minimum instance is 1. Bye-bye cold start problems. You could do that pretty easy. Just one small config in Cloud Run, done. If you want to know more, you can follow the release notes. That QR code will take you to Google Cloud Run release notes. If you are interested more in what Cloud Run has released, at least in the past months or years, I'll just keep it there for 10 more seconds. So I didn't say this. A company here in Brisbane, someone from there, this is taken from one of the customer stories, like Google customer stories. So how many of you have played Fruit Ninja? Jetpack Joyride? Probably a lot of people. Exactly. So these games are made here in Australia by a company called Heartbreak Studios. They are on Google Cloud. And the lead engineer there, Nick, said that using Cloud Run, they could eliminate the need for another engineer, right? Because there was a lot less to manage in terms of infrastructure. They could just set and forget. So this is an actual use case where Google Cloud Run help them basically not hire an extra engineer. Now, if you remember the earlier image, let me try to connect everything back to GCP and Cloud Run. You have your Docker images, you build it with Cloud Build, And then you can push those to artifact registry, which is your container registry. From there, your container as service is Google Cloud Run, which by default, without any configuration, will give you logging and tracing. I can show some of that in the demo. And then it integrates with other Google Cloud services pretty seamlessly. For example, you could connect to a MySQL or a Postgres database on Cloud SQL. You could do event-based things with PubSub, Event Track. And as I said, you could have basically host a static website on Cloud Run. As soon as a file changes on the bucket, it is reflected on the website as well. So yeah, you could do stuff like that. Time for demo. Actually, I'm on time. Good. So I'll show you the easiest way to deploy anything on Google Cloud Run. Basically, you click a button and then it actually deploys. I'm not joking. So you go, essentially, you have your code on anywhere, any accessible public repository. You put this button there. I'm already logged into my Google Cloud account. And this is gonna first, yes, ask me to trust the repository. Yes, I do. It's my code. It's gonna take a bit of time for it to provision the machine. And yeah, it's basically gonna run a script that's called a Google Cloud Run button, which you could add to your repository. And this is how easy it would be to deploy. Of course, I want to authorize because I want to deploy. So it's going to clone the repository, ask me for, I'm just going to use this one for now. So it's just asking me for my Google Cloud project. US Central, fine with it. Now it's actually building the container. So that particular repository has a Docker file and it's building the container, done. Now it's pushing the container, done. Now it's doing a Google Cloud Run deploy, which is this command. And my service should be up pretty fast. That's it. That's how I have already deployed a service. It's talking to a Postgres database. Boom, running. So nothing to a fully working URL in less than a minute. So you just need the code working, deploy, pretty easy. Now, you can do it even without Dockerizing. So let's say there are some, no, not let's say, there are some build packs that Google Cloud supports, for example, Node, Python. And what you could do, I'm just going to play the sped up video because that takes around 2 minutes. So let me just play this one. You could do a deploy from source, which when I actually did it, it took around 2 minutes. I'm just shrinking it to 30 seconds. So it's the same repository, doesn't have any Docker file, right? And I just run a single command that says basically deploy Cloud Run. The main thing is from source, this directory. That's it. And then allow unauthenticated basically means let traffic in from the whole internet. Same thing, maximum instances, minimum instances, which project and which region, right? Same thing, deployed, I got it running. And it goes here, let me pause. So here, yeah, the name of the project, the name of the service, sorry, the project, the reason, same thing, US Central 1, how many maximum instances I would want. I could do minimum instance there as well. Allow unauthenticated basically means allow traffic from the whole internet. Anyone can access it. And the code is here, source this, that's it. And then it took, I mean, when I did it, it actually took 1.5 minutes or something because it does the build pack thing to build the whole thing. But the thing is when it's built, same thing, you get a URL and then I did the same thing, exactly the same code and it runs. This is another way to deploy it if you don't want to use the Cloud Run button. And there are multiple ways to do it. I will just show you something and probably, yeah, so this particular repository is open source, of course. If you go to the cloud build file, this is what I was talking about here, that builds with cloud build, pushes it to a container registry, which is Google's artifact registry now, and then you could deploy it. So if you want like a full-on CI/CD pipeline thingy, this is it. It's not doing much. Basically, yeah, building the container, pushing the container to the container registry, not container registry, artifact registry now, because container registry is deprecating soon, as far as I remember. And then, yeah, Cloud Run deploy, gets the URL working. So what I did with code, you could basically codify it and then run it on Cloud Build, on every pull request, on every merge to master, whenever you feel right. So you could have a full-on CI/CD pipeline. Let me get back, and then I can show you other stuff when I answer questions. So, as I said, yeah, there are multiple Aussie companies using it. The first one being Pet Circle. They say that Cloud Run helped them do the heavy lifting, basically move the heavy lifting to GCP, and it was much more cost effective. Again, Heartbreak Studios, Fruit Ninja people, they said they could reduce their cost from $24 a day to just $4 a day, and could service a wide range of requests per instance that is also configurable on Cloud Run. JRide basically said they could process billions of rows, and Cloud Run with Cloud Run to scale stateless containers, they could do that pretty easily to get all of the data processed. Outside of Australia, Ford uses it. I never knew Ford had 20,000 software developers. There is a full-on 30-minute video if you want to look at it from the recent Cloud Next. Similarly, L'Oreal uses it. They even have their own L'Oreal GPT. I didn't know L'Oreal had 90,000 employees, so they are pretty big. There is another video if you want to have a look on how they are using Cloud Run. MailChimp uses it for scaling their web services. They say it is easy to scale it automatically. BBC uses it. By it, I mean Cloud Run, not just Google Cloud. And they were able to process 3 billion log lines in a day with the container scaling from 150 to over 1,000 containers pretty seamlessly. This actually happened when the news of Queen Elizabeth's death was circulating, and a lot of people were jumping into BBC's website, and they had a lot of load where Cloud Run could scale the containers pretty easily. The second biggest bank in Germany, which has a $3.2 billion profit, uses Cloud Run. It says that they saved 90% of the cost and reduced the toil by 70%. I don't know if they would make these claims if they were using Kubernetes. The top 3 takeaways. I'm not against Kubernetes. 1, use containers. Like, utilize Kubernetes when you actually need it. At least the past 3 companies I've worked in, all of them use Kubernetes. So I said I am not against Kubernetes. And serverless is useful. Like, use serverless when it makes sense, right? Like, for example, if you have your staging environment that's only used 8 hours a day, easily push it to serverless. You'll only pay when someone is actually using it. And yeah, let the big guys do the scaling. Let Google actually handle the scaling. You could do it well, but then probably Google knows better because they made Kubernetes and they know how to scale to billions of users. That's it. Thank you. And that's my LinkedIn profile. If you want to scan in, open to questions. Yeah, go ahead. We can start.
Any example of most of your services are usually like sort of private? So do you have any examples where, you use Run to run and authorize the public one, but then it's now housed internally, and those shouldn't be accessible except from, let's say, internal stuff?
Okay, yeah, that is possible. I don't have an example as such, but yes, that is possible. Service to service auth with IAM or any other form of authentication, even JWT, that's easily possible. That's doable. But I don't have a example of that on hand. Yes. Yeah, yeah, of course. Like a static file could easily be in a bucket. I was just giving you an example of actually trying to link them up so that the configurations could be synced much easily. So not even like a static file, for example, I don't know, even if you have some configuration that could be updated easily by someone changing a file, you could put it on GCP bucket, and then it could reflect back on the service pretty easily. Yeah, like the static file was just an example. It was more like Cloud Run can talk to a cloud storage bucket pretty easily. Anyone else? Yep.
Thanks for the presentation. Cloud Run's my favorite thing in GCP.
Me too.
It's getting pretty trendy these days to bash serverless for cost reasons, especially people like the HH leading the charge to go back to on-prem. Do you see any trends across the companies you've worked at where they might be like, are there any patterns in how people are perhaps using serverless in the wrong way when they do have cost blowouts, and any ways to sort of address that, or did you be lucky enough to work in places where everyone's doing it right?
Yeah, 1, 2, 3. So serverless, at least at the places where I've worked, hasn't been the main bread and butter, like not the main thing. It was being used on the sides. At least that's my professional experience with serverless. Coming back to your point with the DHH, I kind of support him. Let's say if you have like a small SaaS where the traffic is very predictable, like you don't have a public facing thing, right? You know, you have X amount of users and you can generally tell that you'd have Y amount of traffic. So if you don't have a lot of that elasticity needs, I think it's a pretty good bet to take of build versus buy. It's at the end rent versus buy, right? So I mean that depends. That depends. If you have like a generalish SaaS company where the traffic is very predictable, yeah, like not going to the cloud or going back from the cloud could be an option. But if you are like an e-commerce company and you have Black Friday coming in, right? So exactly at that point, you would have wished that you are not on your own thing. You would have wished, yeah, if I could scale my infra by 2 or 3 times for 1 week, I would have loved it rather than, I don't know, putting the racks on. So yeah, and that's the thing. Like where you are at what company and what your needs are would be like probably the first consideration you need to make. Yes, sir.
In serverless, is Amazon's storage.
By serverless, if you are referring to, I think it can. Probably there will need to be some networking gymnastics involved with the VPCs and stuff, but I guess that should be possible. Probably one of these would know much better. Like, would Google Cloud Function or Google Cloud Run be able to get files from a S3 bucket? Yeah, can you get access to S3 buckets? Yeah, that's what I'm saying. Like, there might be some configuration on the VPC level where you want to connect, but yeah.
Or if it's a public.
Yeah. Probably the last question, and I'd wrap up. Yeah, go ahead.
Previously, I worked on a startup, and they were using like VPS servers. And I asked them that why they are not using cloud AWS, and they said that it increases their cost. Like it was like a news website or something like that, and they said that do you agree with that or?
Exactly.
In cloud?
Exactly. As I said, now that's a question of rent versus buy. So if it's a VPS, probably you're buying it or renting it. I mean, if you think of it, the big 3 clouds do put their own markup, right? So you could think of that as well. But as I said, if it's a public-facing website and the traffic is not easily predictable, then you need that elasticity, right? So yeah, probably that's the thing, right? If they're getting 1 million users a day, it's a different question. If they're hardly getting 1,000 users a day, probably getting to the cloud or even using serverless would be a good bet. But yeah, it could even be a question of mindset. I'm happy with what I'm using. Let's just use that. I don't want to explore. That's and change is always difficult. So probably that is one of the reasons that they don't have how do I put it, a good enough argument to use a cloud. But at the back, the main reason would be, yeah, we've been doing this for 5 years. Why do we need to change? It's working. So probably that's the thing. I'll be here so I can take more questions. Thank you.